Today's topic is the height reversing object. Let me start with this example. We have a garage and the vertical mirror behind it. The direct view of the roof is a rounded shape, but in the mirror the height looks like reversed. This is a typical example of the height reversing object. That is, the convexity and concavity of the height are reversed in the mirror. And the true shape of this roof is the flat picture. It is not a 3D object. It is just a picture on the plane, but when we see it from these directions, the direct view looks like a rounded roof, and the mirror image is a reversely rounded structure. So why and how this kind of illusion happens is a topic of today's lecture. Let's consider a simple picture. This is just a picture, but when we see it from these directions, we perceive something, a surface with a convex center. This is one natural perception, but some people can perceive differently. This is a ceiling and some hole is perceived. When we rotate this picture by 180 degrees to make it upside down, then usually the center looks like a concave hole. And some people perceive that this is a ceiling surface with a convex shape. Anyway, there are two interpretations for this single picture. So many people perceive this is a convex surface, and the other one is a concave surface. This way, a single picture has two different interpretations. This is the property of this kind of picture. It's a very general picture. And next, we add something in this picture. We draw a picture of a flower. The flower is also a picture. And if we add this kind of pictures, the interpretation becomes one. That is, the surface looking down from the above, and there is a small hill at the center, and the flower is on top. This is because that the flower represents the direction of the gravity, and so another interpretation, the interpretation of the ceiling, does not happen in this case. So if we rotate the picture becomes nonsense. The surface is has a convex fall, but the flower is falling down. And so the picture becomes nonsense. This is because the direction of the gravity and the looking down interpretation are inconsistent. This is a story in the picture. Next, we make some object like that. The top picture is the same as the picture I have just shown. But if we place this object on the desk surface, horizontal surface, then the mirror image is equivalent to the rotating the 2D pictures in front of us. So the direct view is one posture, and the mirror image is equivalent to the upside down picture. But in this case, the direct view and the mirror image does not give an interpretation that we see a ceiling. This is because in this picture, the picture has a white background, and the edge of the piece of the picture, and so we think that the world in the picture is different in our real world. It's a separated, isolated world. But in this case, we feel that the object is in the same world as we are. The object is on the desk surface, and we are looking down this surface in the same room, in the same world. And so we feel the direction of the gravity directly, and so the other interpretation cannot happen. Always we feel that we are looking at something down, look down the surface. And the direct view is a small hill, and the mirror image is a small hole. Next, we add a flower. This is something vertically standing object. It's not a picture. It's a It's not a horizontal picture. It's vertical something. And so, in the mirror, there's no inconsistency. The flower represents the direction of the gravity, and actually the flower is oriented to the gravity direction. And so in the mirror also it gives the direction of the gravity consistently. And so there's no inconsistency happens. This is the difference between the 3D object projected in the mirror and the 2D picture rotated by 108 degrees. So this kind of visual phenomenon is the same as the phenomenon of the garage roof shape. So let's consider this kind of phenomenon in general. This happens in a very general environment. Suppose that we have a desk surface seen from side, and there is a convex object surface like that. And we see this object from left by represented by the blue arrow, and project the object surface on the desk and draw the picture. Then we get a picture of the desk surface, and then we see this projected picture in the direction shown by the red arrow, that is opposite and looking down by the same angle as the blue direction. Then we perceive the another surface which is height reversed from the original surface. In other words, we say that when we see the horizontal picture in two directions by the blue arrow and the direction represented by the red arrow, then we perceive mutually height reversed surface structure. This is a very general property, and we call it, this is a height reversal property. And this perception is consistently found uh, only when we have no occlusions. If we have occlusions, then the picture, when we see from another angle, some inconsistency happened. But if all the surface is visible and there's no occlusion, this height reversing property happens for any surface. This is a very general theory. And this is a basic mathematical background from which we can perceive this kind of height reversing visual phenomenon. Let me show some other examples. In this case, we have a trapezoidal structure, and in the mirror, the height is reversed. And when we add vertical object, it represents the gravity directions consistently and consistently in the mirror also. And so we have this illusion naturally. Another picture. This surface is shown by one group of stripe curved lines, but the same visual phenomenon can be observed. And the other one is something a ridge structure, but this is also a plane picture, and in the mirror the height is reversed in the same way as we have shown. No inconsistency can be observed. This kind of height reversing object can be drawn in a very wide range of structures. This is also a planar picture, but when we see it, we have the two different 3D structures, the direct view and the mirror image, height reversed pair of objects. The red cone placed on top is placed at the bottom in the mirror. Several times before, we gave another lecture titled Height Reversing Staircases. And that is based on the same mathematical properties, height reversing properties. Staircase is a typical example of 3D structures which have the height differences, and so I showed it first. But not only the staircase structures, but also many various kinds of 3D surfaces can arise the same height reversing properties. The only condition for that is that there's no occlusion on the surface. The whole surface is visible from one direction, and so if we draw its picture on the horizontal plane and see it from the opposite side, we have the height reversed structure. This is another example. It's like a tower on top of the rectangular hill, but in the mirror, the center looks like the bottom of the hole. More general structure is shown in this example. The very general kind of surface, and we can see that there is no occlusion, no part hide the other. The whole surface is visible from this direction, and so we can enjoy height reversing visual phenomenon. Place something on the face, then in the mirror, we look at, it appears to be very different places. So today's lecture is visual phenomenon that the same horizontal picture looks like the different height when we see it from the opposite side by the same view angle. Finally, let me give a quiz. Here the object is reflected in the mirror in the same way, not height reversed, but the chicken changes its place. Hen on the bottom in the direct view, the rooster on top in the mirror. So please consider what is happening, what is the trick. Thank you very much.